This lesson is going to be on basic trig graphs. So our objective is I can graph trig functions. We're going to look at sine, cosine, and tangent, and we're going to look at those values and watch how these graphs over time repeat themselves. So that, first of all, let's define some terms. Periodic means, if a function is periodic, it means it repeats. What we're going to see is that these graphs, as you go horizontally, you're going to graph it, and then it's going to start repeating the same graph, and it's going to do it over and over and over again. Now the period, or we sometimes call it the cycle, is that value horizontally by which it starts repeating. So if it, after 360 degrees, if it repeats again by the time we get out to 720, then it's got a period of 360, because that's how far until it starts repeating itself again. The amplitude, on the other hand, is how far up and down the graph goes from the middle. So in this case, the middle of our graph is the x-axis. How high up does it go from that, and how far down does it go from that? So we're going to look at those values. We're going to look at this table now. This has got a lot of information on it. We're going to start with just the sine graph here, and then we'll do cosine, tangent afterwards. The sine graph, notice we did angles in degrees, which is what I'm going to use on my graph. You could also use radians, so I put those there for comparison to get familiar with them. But I'm going to start with these sine values. So 0 degrees, we have 0 for the y value. Now notice I'm going to do the ones in blue here. I'm going to skip to 45 degrees. 45 degrees is at about 0.7, so it's right about there. So our value for that is about right there. And then at 90 degrees, notice it goes up to 1. And then we'll keep going. We're going to go at 135 degrees is halfway between there. It's about 0.7. At 180 degrees, it's at 0. I'm going to keep going. I'm going to go to 270. Notice at 270, I'm going to go with -1 down here. And then 360, I'm going to be back at 0. So this graph looks like this. And then notice it goes down like this. And then what will happen is, if we were to continue this out to 720, that's one period, because now it will start repeating itself. It'll go up, back again through the axis, down again through -1, and repeat out to 720. Or if we went in the negative direction, it would do the same thing. It would go down first, and then it would go back up here, up to the top. And then notice, if I were to follow this, it goes up, down, and then repeats itself. This sine graph is oftentimes the typical one we look to see that periodic motion about how it repeats. Things like sound waves do that, and that's where some of our applications are. So that's what a sine graph looks like. It starts at 0, and it goes up to 1, down to -1, back to 0, and then repeats itself. Now, looking at our cosine graph, what we're going to do is, when we look at 0 degrees here, notice on the cosine line, it starts up at 1. And what happens is, it goes down again at 45 degrees to about 0.7, so about right there, and then it goes at 90 degrees through 0. And then we'll skip over to 180, it goes down to -1, and then it goes through 270, it goes through 0 again. And at 360, it goes back up to 1. Now, what I want you to notice on this chart is how repetitive this chart is. So when we talk about periodic, notice how often in this cosine, the 0.7 repeats itself, but sometimes it's negative and sometimes it's positive. That happens over and over and over again because of this idea of going into the negative quadrants and then up into the positive quadrants. That repetition is the periodic nature of it. If we were to keep going, this graph would go for this is one period, because it would repeat itself at 360. And then if we would keep going, we'd go back through 0, down through -1, back through 0, and back up to 1. And if we were going in the negative direction, we'd go down, back, and then it would again end up back at 1. So this idea, it follows the same pattern. In fact, notice the shift of 90 degrees. 90 degrees, and it looks like a sine graph. That's the idea of what's called a cofunction. A cofunction means why it's called co is because complementary angles adding up to 90 degrees, if you have the sine of an angle and the cosine of its complement, those are going to be equal to each other. So sine of 30 and cosine of 60, 30 and 60 are complementary, those two equal each other. That's why we call it a cofunction. Let's look at the tangent graph. Now, if we look at these values, what we should spot is that these repeat themselves a lot quicker when we look at these different values. So what I want to do is I'm going to start at 0, 0, it goes right here, and then what happens is when I get to 90 degrees, it's undefined, which means that that is an asymptote. So in between these values, it kind of gradually slopes up like that, and then down here, notice it's also when we get to, in this repetitive nature at negative 90, it's also going to be an asymptote. And every 180 degrees, that's the period for tangent, every 180 degrees, there's going to be an asymptote on the graph because notice at 270, it's also undefined. And so we just skip over every other one, put in our asymptotes here. And so the repetitive nature of this is it's going to look that same way as we graph it, where it comes up into the axis and then it goes out and it chases after that asymptote but never gets there. And so here the period is no longer 360 like it was with sine and cosine, but here the period is equal to 180 degrees. So what I've got here graphed, notice I've got 1 period, 2 periods, 3 periods, 4 periods and a half. There's 4.5 periods graphed on this graph. Separated, each period can be separated by asymptotes. So as we look at our basic trig functions of sine, cosine, and tangent, these are the basic graphs for them, where 1 period for a sine goes over 360 degrees or 2 pi. Its amplitude is 1 because it goes up to 1. Cosine, it starts up at 1, but it also has a period of 360 and an amplitude of 1, but it starts up at 1 before it ends up at 1 to finish a full period. And tangent, it has a period of 180 degrees because it has an asymptote at negative 90 and 90, and then it graphs goes off to infinity, negative infinity on one side and infinity on the other for the basic graphs. So there you have our basic trig graphs.